Okay, we're picking up the second part of the Chapter 14 lecture with network addressing. Network adapters normally have two types of addresses assigned to them, a MAC address and an IP address. A MAC address is a 48-bit unique number that is burned into a ROM chip located on a NIC and is represented in a hexadecimal number. A MAC address is unique for every computer on the network. However, the MAC address has no scheme to it except that the first 24 bits represent the manufacturer. The MAC address is known as a layer 2 address or a physical address. And the chart on the top of page 747 there shows the formats for MAC addresses. Okay, so you can take a look at those. The IP address is a much more organized way of addressing a computer, and it is sometimes known as a layer 3 address in reference to the OSI network layers. There are two types of IP addresses, IP version 4 and version 6. IPv4 is most common IP addressing used on LANs. Your IP4 address is a 32-bit number that is entered into a NIC's configuration parameters. The address is used when multiple networks are connected and when accessing the internet. Your version 4 address is shown using dotted decimal notation. You can see it here on the example there where it has the IPv4 address at 192.168.1.64. That's the standard format. Version 6 addresses are 128 bits in length and shown in hex. Version 4 addresses are used by corporate devices and by some internet service providers. And more conversions of 4 to 6 are coming soon. An example of a V6 address is there as well, link local IPv6 address. You can see there the standard format there on the slide. Each set of 4 digits represents 16 bits. Anywhere there are just 3, such as 13E, there is a 0 in front that has been left off, so it would be 013E. Anywhere there are double colons, a string of zeros has been omitted. Okay? Only one set of double colons is allowed in a version 6 address. Many network cards are assigned version 6 addresses even if version 6 is not being used. Version 4 addresses are grouped into 5 classes. You have class A, B, C, D, and E. Class D addresses are used for multicasting or sending traffic to a group of devices, such as in a distributed video or web conference session. And Class E addresses are used for experimentation. Classes A, B, and C are used by network devices. There on the bottom of the page on 747, you have a table there that shows your first octet of the IP address. For Class A, it'd be numbers 0 to 127, B 128 to 191, and C 192 to 233. Alright. An IP address is broken into 2 major parts. The network number and the host number. The network number is the portion of the IP address that represents which network the computer is on. All computers on the same network have the same network number. The host portion of an IP address represents the specific computer on the network. All computers on the same network have unique host numbers or they will not be able to communicate. The number of bits that are used to represent the network number and the host number depends on which class of IP address is being used. And it shows you there examples of Class A. It shows your network and your host there. With a Class A address, the first 8 bits represent the network portion and the remaining 24 represent the host number. With Class B, the first 16 bits represents the network, and the remaining 16 represents the host. And with Class C, the first 24 represent the network, and the remaining 8 represent the host. Alright, and then a broadcast address is the IP address used to communicate with all devices on a particular network. In addition to assigning a computer an IP address, you must also assign a subnet mask. The subnet mask is a number that a computer uses to determine which part of the IP address represents the network and which portion represents the host. The default subnet mask for a Class A IP address is 255.0.0.0. The default subnet mask for Class B is 255.255.0.0. The default mask for a Class C is 255.255.255.0. Okay, so if you look at table 14.14 on page 749 there at the bottom, it recaps your IP address information. So for Class A, your first number is in the range of 0 to 127. Your network host number, the first set of bits there is your network, and the first 8 and the remaining portion is your host. Your Class B, your first number is 128 to 191. It's in that range. And your first 16 is your network, the NN. And then the remaining portion, the last 16, is your host. And then on C, your first number is in the range of 192 to 223. And your first 3 will be ends because that represents your network, and your last one there is your host. And then it shows, recaps again your subnet mask there in that last column. Subnet masking. Okay, the purpose of the subnet mask is to tell you what portion of the IP address is the network part. The rest of the address is the host portion. The network part of any IP address is the same ones and zeros for all computers on the network. The rest of the ones and zeros can change and be unique addresses for the network devices on the same network. Important rules that relate to subnet masking are: the network number cannot be assigned to any device on the network. The network number contains all zeros in the host portion of the address. Note that this does not mean that the number will be 0 and decimal. This is explained later on. The broadcast address, which is the number used to send a message to all devices on the network, cannot be assigned to any device on the network. The broadcast address contains all ones in the host portion of the address. Note that this does not mean that the number will be 255 in decimal. So if we look at an example, there, starting on page 750, if you consider the IP address and mask used in an example before, 10.104.10.88 and 255, 255, 255, and 0, and you put the numbers in binary, one number on top of the other, to see the effects of the subnet mask. So there, about middle ways or a little more there on 750, it shows you that IP address broken down into binary, and it shows the subnet mask broken down into binary. Okay? The ones in the subnet mask show which bits in the top row are the network part of the address. Okay, so it's a Class C because the first 3 are showing your network address. The subnet mask is always a row of consecutive ones, where the one stop is where the network portion of the address stops. Keep in mind that this does not have to be where an octet stops, as in the example. A good technique is to draw a line where the ones in the subnet mask stop, as shown there close to the bottom of the page. At this point, there is no other purpose for the subnet mask. You can get rid of it. Okay? It's the network portion. All ones and zeros to the left of the drawn line are the network portion. Okay, so the binary portion there You can get rid of all of that. All devices on the same network will have the same combination of ones and zeros, and all ones and zeros to the right of the line are the host portion. The network number, the IP address used to represent an entire single network, is found by setting all host bits to 0. The returning number is the network number. The resulting number is the network number. The network number for the network device that has the IP address 10.104.10.88 is 10.104.10.0. To find the broadcast address, the IP address used to send a message to the devices on that network, you set all the host bits to 1. So the broadcast address would be 10.104.10.255. Okay? This means that a host can be assigned any addresses between the network number 10.104.10.0 and the broadcast address of 10.104.10.255. Another way of stating this is that the IP addresses 10.104.10.1 through 10.104.10.254 are usable IP addresses on the 10.104.10.0 network. I know that's a little confusing. You guys may need to read back through this again. Alright, consider the IP address 192.168.10.213 and the subnet mask of 255.255.255.224 assigned to a computer in a college. What would be the network number and broadcast address for this computer? Alright, so again, you would break it down into binary, the network address and the subnet mask, and you would draw your line where all of your all ones there across the bottom stopped. And when you remove the subnet mask and you set all the host bits to 0, the network number for that device would be 192.168.10.213. Your would be 192.168.10.192. Okay? So, to find the broadcast address, you would set your host bits to 1. So, the broadcast address for the network device that has 192.168.10.213 is 192.168.10.223. Notice how all 8 bits are used to calculate the number 223 in the last octet. Valid IP addresses are any numbers between the network number 192.168.10.192 and the broadcast number of 192.168.10.223. In other words, the range of usable IP addresses is from 192.168.10.193, one number larger than the network address, through 192.168.10.222, which is one number less than the broadcast address. Practice problems at the end of the chapter will help you with this concept. So you might want to look at that some more. You may see 1 or 2 of these on the final. I know it's a little confusing at first if you haven't had any of the networking classes already. Some of you guys probably have already had this and it's easy to you by now. But for the ones that haven't, read back through this, look over it again, look at the examples. If you have questions, let me know on that section. I know subnet masking can be kind of confusing to start with. Moving on to wireless networks. Wireless networks transmit data over the air using either infrared or radio frequencies. Most wireless networks in homes and businesses use radio frequencies. Wireless networks operates at layers 1 and 2 of the OSI model. Your access point, or AP, is the central connecting point for a wireless network, coordinates wireless access for wireless devices, commonly connects to a wired network. Your wireless NIC is integrated into a wireless device such as a laptop, netbook, or tablet. Wireless routers is an access point router device that normally has both wireless devices and a few wired Ethernet ports. And then your wireless bridge is a physical device or software that connects two or more networks. It could connect a wireless network to a wired network. An example of a wireless bridge is a building where all devices connect wirelessly to the bridge. The bridge connects to the wired network, which eventually connects to the internet. Many access points or wireless routers can be placed in bridge mode. An SSID is your service set identifier. It's a number that's your service set identifier. Each access point is assigned an SSID. It's a 32 alphanumeric characters used to differentiate between different wireless networks. Wireless NICs can automatically detect a wireless network, or the SSID can be manually configured. In addition to SSIDs, an access point can be configured with a password and a channel ID. The channel ID defines at what frequency the access point operates. With APs that have a 2.4 gigahertz antenna, up to 14 channels are available depending on what part of the world the wireless network is being deployed. In the US, only 11 channels are used. You have a table there at the top of 758 that shows channel ID numbers and their frequencies for wireless channels. You can look over those on your own. Wireless cards and access points can have either external antennas or antennas built into them. An antenna is used to radiate or receive radio waves. Some access points also have integrated antennas. Wireless NICs and access points can also have detachable antennas depending on the make and model. There are two major categories of antennas, which are omnidirectional and directional. An omnidirectional antenna radiates energy in all directions. Integrated wireless NICs use omnidirectional antennas. A directional antenna radiates energy in a specific direction. Each antenna has a specific radiation pattern. A radiation pattern is the direction the radio frequency is sent or received. It is the coverage area for the antenna that is normally shown in a graphical representation in the antenna manufacturer's specifications. An important concept in relationship to antennas is gain, and in order to understand gain, an isotropic antenna must be discussed. Isotropic antenna is not real. It's an imaginary antenna that is perfect in that it theoretically transmits an equal amount of power in all directions. Antenna gain is measured in dBi, which is a measurement of decibels in relationship to an isotropic antenna. Some antennas are shown with measurement of dBd instead of dBi, and this measurement is referenced to a dipole antenna. Gain is actually logarithmic in nature. Okay, so imagine a round balloon that is blown up. Balloon represents an isotropic radiation pattern. It extends in all directions. Push down on the top of the balloon, and the balloon extends out horizontally, more horizontally than it does vertically. Push on the side of the balloon extends more in one horizontal direction than the side being pushed. Now think of the balloon shape as an antenna's radiation pattern. Antenna designers can change the radiation pattern of antenna by changing the antenna's length and shape. Similar to how a balloon's look can be changed by pushing on it in different directions. In this way, different antennas can be created to serve different purposes. A site survey is an examination of an area to determine the best wireless hardware placement. To take such a survey, temporarily mount an access point. With a laptop that has a wireless NIC and site survey software, walk around the wireless network area to see the coverage range. Most vendors provide site survey software with their wireless NICs. Okay. Multiple input, multiple output, or MIMO, uses multiple 2.4 gigahertz and 5 gigahertz antennas. These antennas may be external or built into the wireless device. By using multiple antennas, greater wireless speeds can be achieved. And then if you look on page 764 at table 14.7, it talks about your IEEE 802.11 standards. Okay, the IEEE 802.11 committees define standards for wireless networks, and they can be confusing. The chart shows them here. 802.11a came after the 802.11b standard. It has speeds up to 54 megabits per second, but is compatible with 802.11b, and it operates in the 5 gigahertz range. Alright, 11b operates in the 2.4 and 2.4835 gigahertz radio frequency ranges with speeds up to 11 megabits per second. 11e provides standards related to quality of service. 11G operates in the 2.4 gigahertz range with speeds up to 54 megabits per second and is backward compatible with 802.11b. 11I relates to wireless network security and includes advanced encryption standard for protecting bits or protecting your data. 11N operates in the 2.4 and 5 gigahertz ranges and is backward compatible with the older 802.11a, B, and G equipment. Speeds up to 600 megabits per second using MIMO antennas. Okay. Alright. There in your book on the next page, 765, it talks about wired or wireless NIC installation. I'm not going to go through that. You guys can read through that on your own of how to install a NIC. We're going to go on to Dynamic Host Configuration Protocol, or DHCP. It's a protocol used to assign IP addresses to network devices. DHCP server contains a pool of IP addresses. When a network device has been configured for DHCP and it boots, the device sends out a request for an IP address. A DHCP server responds to this request and issues an IP address to the network device. DHCP makes IP addressing easier and keeps network devices from being assigned duplicate addresses. Windows computing support automatic private IP addressing, which assigns an IP address and masks the computer when a DHCP server is not available. An alternative configuration can also be used. An alternative configuration is used when a DHCP could not assign an IP address, such as when there are network problems or the server is down. An alternative address could also be used on a laptop where at work DHCP is used, but at home the addresses are statically assigned. Another important concept that relates to IP addressing is a default gateway. It's an IP address assigned to a network device that tells the device where to send a packet that is going to a remote network. Default gateway addresses are important for network devices to communicate with network devices on other networks. The default gateway address is the IP address of the router that is directly connected to that immediate network. Keep in mind that the primary job of a router is to find the best path to another network. Alright, and then a DNS is your domain name system server, sometimes called a domain name server. It's an application that runs on a network server that provides translation of internet names into IP addresses. DNS is used on the internet, so you don't have to remember the IP address of each site to which you want to connect. For example, DNS would be used to connect to Pearson Education by translating the URL of www.pearsoned.com into the IP address of 159.182.16.65. Alright. And then client-side DNS is configuring your computer to use one or more DNS servers. A computer can be programmed for one or more DNS server IP addresses using DHCP, and the DHCP server must be configured for this. Otherwise, a technician can manually configure the system for one or more DNS server IP addresses. Okay? Either in your network area of your XP machine or your network and sharing center control panel for Vista and 7. All right. Um, your book talks about wireless broadband and virtualization network issues. I'm going to let you look at some of that stuff on your own. If you have questions about it, let me know. Access point router installation and configuring network printers. I'm going to let you look at all of that on your own. The next thing we're going to look at is network troubleshooting. There's some commands that you can use there in the command prompt to help you troubleshoot a network. The ping command can be used to check connectivity all around the network. The IP config command lets you see the current IP configuration. NS Lookup is a program tool that helps with DNS server troubleshooting. DNS Lookup allows you to see domain names and their associated IP addresses. And then the Tracert command is also a commonly used tool that is used to display the path a packet takes through a network. You have some common network terms there on pages 776 and 777, such as ARP, which is your address resolution protocol, backbone bandwidth, broadband, infrared, TCP, voice over IP. You guys need to take a few minutes and look over this chart. Some of these definitions might be on your final as well. If you have any questions about any of the terms, common network terms, just let me know. You also have your TCP IP protocols and port numbers, such as for your DNS, your common port is 53. And it's a translation of internet names and URLs into IP addresses. You have your file transfer protocol, or FTP. Common ports are 20 or 21, and it's for sending and receiving of files from one computer to another. HTTP is port 80, browser-based internet communication standard. HTTPS is your secure transfer protocol. 443 is your common port, and it's encrypted HTTP communications. IMAP, or Internet Message Access Protocol, is common port 143. That's email, of course. LDAP is Lightweight Directory Access Protocol. Common port's 389, and it's used to access, maintain, and distribute directory database type information. MAPI, or Messaging Application Programming Interface, doesn't list a common port. Microsoft proprietary protocol, normally used with remote procedure call. Okay, NTP, or Network Time Protocol, common port's 123, and it's used to synchronize time between network devices. POP3 is your Post Office Protocol version 3. It's email, and your common port's 110. Remote Desktop Protocol, or RDP, your common port's 3389. Microsoft Protocol used to connect to a remote computer. Secure File Transfer Protocol, or SFTP, common port's 22, and it's your file transfer that's secured. Server Message Block, common port 445, means of providing access to shared network devices and files. SMTP, or Simple Mail Transfer Protocol, a common port's 25, is used to transmit email and commonly used in conjunction with multi-purpose internet mail extensions. SNMP is Simple Network Management Protocol. It has several ports listed: 161, 162, 10.161, 10.162, used to monitor, communicate with, and manage network devices. Your Secure Shell, common port's 22, means of secure data communication, including remote connectivity of devices and file transfer. And then your Telnet, your common port's 23, and it's used to connect to a remote desktop or remote network device, but Telnet is not secure. TCP/IP layers and associated protocol standards. Your application layer, HTTP, HTTPS, Telnet, Secure Shell, FTP, DNS, your transports, TCP, UDP, Internet, DHCP, ICMP, IP, and your network access, ARP, 802.3, 802.11, ABGNN. Okay, and then some network connection types. Plano telephone service. You have a chart there on 783 that shows the speeds for these. 2400 bits per second to 115 kilobits per second. Analog phone lines, dial-up networking. ISDN, Integrated Service Digital Network, another method for dial-up networking, 64 kilobits to 1.5 megabits. This is a digital line. Frame relays are 56K to 1.544 megabits. 56K point to point is a guaranteed bandwidth between 2 points of 56K. T1 is 1.5 megabits guaranteed bandwidth. T3 is 44 megabits guaranteed bandwidth. DSL or digital subscriber line is 256 kilobits and higher, shares data line with voice line. Broadband cable or satellite is 56 kilobits, broadband satellite to 30 megabits and higher. ATM or asynchronous transfer mode is up to 2 gigabits. And Metro E or Metro Ethernet has speeds of 1, 10, 40, or 100 gigabits using Ethernet technology to connect to the internet or to connect multiple sites and buildings. And then your soft skills. Some of the mobile app stuff, the slides really didn't go into it that much. If you have questions on anything that we didn't really dive deep into because it's covered in networking classes, just send me an email and I'll address them. But I told you we're going to do a broad overview and not really dive deep into this chapter because you guys take a networking class as part of the curriculum. Your soft skill is being proactive. A good technician is proactive, which means that the technician thinks of ways to improve a situation and anticipates problems and fixes them before being told to do so. A proactive tech follows up after a service call to ensure that a repair fixed the problem rather than waiting for another help desk ticket to come through. A proactive technician, as a student, practice being proactive in your life. Some examples of how you can be proactive is as a technician at a college, you're responsible for any problems logged by computer users through the help desk. The tech is also responsible for maintaining the computer classrooms used by various departments. Each term, the tech reloads the computers with software updates and changes requested by the teachers. A proactive technician checks each machine and ensures that the computer boots properly and that the load was successful. The tech does not wait for the first day of the term or for a teacher to report a problem. Okay. The opposite of being proactive is being reactive. A reactive tech responds to situations only when there's a problem reported. The technician is not looking for ways to avoid problems. Okay. As a student, you want to become proactive. Start an assignment a day before you would normally start it. Talk to your teachers about your grades in advance, not the day before the final or the day of the final. That kind of thing is proactive. Bringing pencil and paper to class, even if you're not sure if you'll need it. All of those things are proactive. Like I said, I didn't dive deep and really explain in detail every little thing in the chapter. But as you're reading through it, if you have questions, just send me an email and I'll answer you directly, or if I think it'll benefit the whole class, I'll post something for everybody.